Okay, so in the previous video we looked at, or the previous lesson I should say, we looked at pure imaginary numbers, and we talked about and dealt with some different operations as far as adding, subtracting, multiplying, and dividing when we're dealing with pure imaginary numbers. But today we're going to talk about complex numbers. Well, first off, we need to understand what is a complex number. So again, when we have numbers in the form bi, where b is a real number, we call those our pure imaginary numbers. So like 7i, so numbers in this form like 7i, 3i, negative 10i, those would be our pure imaginary numbers. Now if I have a real number like 3 or 6 or negative 12 and a pure imaginary number added together, the sum is what we call a complex number. Now that's what the definition of a complex number is basically saying in this box, is that if we ever have a number in that form, a plus bi, where a and b are real numbers and I is equivalent to square root of negative 1, then like I said, we have a complex number. So in a complex number, a plus bi, a we refer to as the real part. That again is the part that would have just a 7 or negative 2 or 13. And the bi, that part there is the imaginary, or the pure imaginary part. Now, everything that we know about as far as our basic operations of adding, subtracting, multiplying, and dividing of real numbers also hold true for complex numbers. Now, if you want, you can look at page 428 to see some more information about that, but we're going to look at some basics here. In this activity, we're just going to look at, well, what happens if I have, these are two complex numbers, 2 plus 3i is a complex number. We're going to add that to another complex number of 6 plus 9i. Now when we add them together, we add together the like terms. So 2 plus 6 would be 8. 3i plus 9i would be 12i. Easy enough. Well, let's throw some negatives in here. Let's say if I have a positive 4 plus 7, well, that's going to be 11. But this is a negative 3i plus a positive 5i. Negative 3i plus 5i would be a positive 2i. So I'm going to write this as plus 2i. And here I have a negative 16 plus a positive 4. Negative 16 plus 4 is negative 12. Moving on to the imaginary part, the 5i plus negative 8i. Add those together. Well, 5 plus negative 8 is negative 3, so this will be minus 3i. So adding is relatively easy. It's when we start to get into subtraction that's a little bit trickier. One way you can do this is we really only need parentheses around something if there is something outside of there that we need to distribute. So with this 4 minus 3i, there's nothing outside of there, so I'll just write this as 4 minus 3i. But this negative outside of here applies to everything inside the parentheses. So we can write this as minus 6 and minus 5i. So now when I go to simplify this, I combine like terms. 4 minus 6 is negative 2. Negative 3i minus 5i is negative 8i. And that would be my answer. Those can't be simplified. Or for the next one, again, I have a negative outside of here, so that applies to both the 7 and the 9i. So first off, I'd have negative 2 plus I. Nothing changes with the first two. But then I distribute the negatives. So that, like I said, it'll be negative 7 minus 9i. So when I go to simplify this, negative 2 minus 7 is negative 9. I plus negative 9i would be negative 8i again. Now, you don't have to necessarily distribute it as long as you can remember that we're subtracting here. Here's what I mean. With this one, if we want, we could take 8 minus 1. Well, 8 minus 1 would be 7. And now I'm going to take negative 4i minus negative 1i. Well, negative 4i minus a negative I would be negative 4i plus I, which would be negative 4i plus I would be negative 3i. So that's a faster way to do it. However, fast isn't always better because you can always make a lot of mistakes when you try to do it that shorter way. We'll skip step 3 here, but I want to move on to talking about multiplying. If we have the distributive property, works the same as before. If I have a number outside the parentheses, I'm going to multiply that times all the items inside the parentheses. So 4i times 8 is going to be 32i. 4i times 5i, well, that's going to be plus, well, 4 times 5 is 20. I times I is I squared. Now remember, I squared is the same as negative 1. So I want to put this in a plus bi form, so I want to put my real number first. 20 times negative 1 is going to be my real number, so it's going to be negative 20. On the 32i, that's my pure imaginary number, so I'm going to write that as plus 32i, so that would be my answer. So remember, the only time that our I changes to a negative 1 is if it's an I squared. Let's look at the next example. Here I'm going to distribute the 7i through. So 7 times 9 is 63, so this will be 63i. 7i times negative 6i is going to be negative 42, but it'll be I squared. Again, I squared is the same as negative 1. So negative 42, that's what this is. This is a negative 42 times negative 1 is a positive 42. So I'm going to put that first. And then the 63i is positive, so it'll be plus 63i. So there's my answer, 42 plus the 63i. So again, the distributive property works the same as before. So that means that if we have a situation like this, where I have 6 minus 2i times 4 plus 3i, the distributive property still works. But what we're going to do is we're going to take the I squared, because we're going to use the distributive property, and then if we have an I squared, we're going to use the fact that I squared is negative 1 to simplify our answer. Now earlier when we did these, I showed you that we could multiply by using what I call the extended distributive property, or the FOIL property. So I'm going to take 6 times 4, which is 24, and 6 times 3i, which is 18i. Now I'm done with the 6, so I'm going to take and do the same with the negative 2i. Multiply that times 4. Well, negative 2i times 4 is negative 8i. And negative 2i times 3i would be negative 6i squared. Now again, I squared is the same as negative 1. So when I go to simplify this, this is going to be 24 plus 18i minus 8i, that's 10i. And negative 6 times negative 1 is a positive 6. We want to make sure we put this in a plus bi form. So I want to put the real number first. So 24 plus 6. We can add those together. 24 plus 6 is 30. So my final answer is going to be 30 plus 10i. You could also use the window method to multiply these. I'll show you that with this example. So I could put 5 plus 7i on top and 6 minus 2i on the side. Multiply these together, so 6 times 5 is 30. 6 times 7 is 42i. Negative 2i times 5 is negative 10i. And negative 2i times 7i is negative 14i squared. However, again, remember that I squared is the same as negative 1, so this box is the same as positive 14. Okay, so now, when I go to write my final answer, I'm going to add together my real numbers. So 30 plus 14 is 44. And 42i minus 10i is 32i. And there's my answer. So you can use either method. You can either use the distributive property, the extended distributive property, or the FOIL method for simplifying these types of problems, or you can use this window method. And we're going to stop there with this video, because in your first assignment, that's what we're going to focus on, is multiplying complex numbers. In the next video, we're going to learn about how to divide by complex numbers. So again, we'll stop here. So good luck on your assignment.